So in this video, what we're going to do is examine how to get the equation for the height of a rider as a function of time based on lesson SLT number 4 that we looked at. And here we're given the graph and want to create the equation. So to get the equation, we have to identify all of the components of the equation, beginning with the radius, from which we called on the graph the amplitude. And typically, actually, before I answer that question, I think the first thing you'd want to know and identify is what is the midline. And the midline is comparable to where the distance from the center of our Ferris wheel simulation to the ground. So as I look at this graph, I can see definitively that the midline is going right through all of the middle points that consist of 15 as a height on this graph. So as I draw that midline, that's where I'm seeing all of my middle points cutting right through 15 feet. So I'm going to use that as a representation for my height, okay, above the ground, center above the ground. So we're going to say, we'll put it right here, y equals 15 feet. Now you probably think, okay, why do we say y equals, right? So if we say y equals, it's because it's a horizontal line that we just drew through that entire graph, okay? And so that is why we said y equals. Y equals 15 feet. Now that you have it, you can identify the radius, which on the graph would be the amplitude. So now if I actually took how far away and counted how far away measurement wise the midline was from the maximum point, and this is a maximum point where this is a minimum point, right? And if I were to measure that distance out and calculate it, I would take the maximum value, which in this case is 25, and subtract it from where the midline is, and I would get a difference of 10. But if I did the same thing for the minimum value, with using that minimum value with the midline, I would take the midline and subtract it by the minimum value. You always want to subtract the highest minus the lowest value, whatever that is. And again, you see we get 10. So that concludes that we have 10 feet here as my radius. Now the period tells me how long it takes to make one full rotation. In other words, on the graph, it tells me how long does it take for this shape to repeat. So right now, counting out the first 5 points, that's the first rotation of this graph. This would be the second rotation of this graph. And so what I am noticing is this shape repeats every 10 seconds, because you notice here it landed on 20 seconds, right? On the second rotation. So that meant that on the first rotation, it had to have ended at 10 seconds, which is in the middle of 8 and 12 on my chart, on my number line. So I'm going to put down 10 seconds as the period of this graph. Okay, so now that I have these 3 components, I am now ready to write my equation, okay, for this graph in this image. So here's what we're going to write. I'm going to put it right here. First of all, we're going to name the equation h of t, which stands for height as a function of time. So you always want to make sure you give your equation a name. Components of the equation you want. Okay, you begin with what was your midline. That was 15 feet. You add that to whatever your radius or your amplitude was. So your amplitude was 10. Remember, this is based off of a sine equation. This is a sine graph because the path of this shape of the Ferris wheel is how this graph unfolded. So it's sine of, and now you have to determine what your angular speed is. Now, if you recall from before, we calculated angular speed by finding basically how many degrees were in a circle. Well, we all know that's 360 degrees. But we take that and we have to divide it, right? We have to divide it by the number of seconds it takes to make one full rotation in this graph. Well, we do know that now. It takes 10 seconds on this graph. So when I divide this, I end up with a unit of 36 degrees per second. So since my angular speed, that's what this is referencing, is 36 degrees per second, I'm going to come back to my equation and complete it by writing 36 degrees t. And this will represent my equation of my height of the rider as a function of time t, 15 plus 10 times sine of 36 degrees t. And that is how you find your height equation.